All right, folks, welcome back to the second half of class. So in this second half, we're going to be focusing on 5.5, which is solving exponential and logarithmic equations, all right? So we're going to start with the exponential ones, and then the second half of this will be on log equations. So it'll be very similar to what we just did, just a little bit more practice. Because I know it's like with new topics in math, the more practice you can get, the easier, the more sticky it becomes in your brain. Okay, so that's the goal here, is we're going to try and blow through a bunch of examples. Depending on the time, I may skip a few examples, but I will make sure to put the work for the examples in the notes before I upload the notes. So we may not go through every example if we don't have time, but I'll try and pick and choose the ones that I think are going to be most relevant. And then anything we don't cover in the next 45 minutes, I'll have the answers written on the complete notes when you access this on Canvas, okay? So let's go ahead and get started. All right, so 5.5 is solving exponential and logarithmic equations. All right, so let's review those real quick, even though we just saw them today. So we've got the exponential form, and to do that, to solve these equations, we're going to use logarithms. All right, in fact, we're going to isolate the exponential, rewrite it in log form, and then solve for our unknown. On the flip side, when we have a log form, we're going to condense it if we need, isolate our logarithm, and then rewrite it in exponential form, and then solve for our unknown. Okay, so the two of these go hand in hand, exponential forms of equations and logarithmic forms of the equations, because they undo each other. So if we have something in the exponent we don't know, we use logs. If we're logging something that we don't know, we use exponential, okay? All right, so let's try some practice. All right, do I need to isolate the exponential here? Or is that step already done?
It's already done.
It's already done. All right, so that means that we're going to go ahead and rewrite it in log form. Log, what's the base here?
10.
Nope.
Oh, sorry. It's going to be 7.
Nope. That's 4. The base is the number raised to the power. All right, so 4 is our base. So we're doing log base 4 of the number on the other side equals our exponent. Okay? So if I were to write this out in words, I've got a base to the unknown equals a number. Okay? So the way we rewrite that is we do log base of our number equals the unknown. Okay, and that's something that we want to make sure we know really well, is how to go back and forth between those two forms. All right, once we have log base 4 of 7, if we want to put this into the calculator, how do we type that in? If we don't have like a very new calculator, we have an older school calculator.
Log 7 divided by log 4.
Perfect. Log 7 divided by log 4. And let's round to 3 decimal places. We should get something about that. Okay? And you can, on your own time, plug that back in, make sure that you get 4 raised to that power should give you 7. Okay?
I got 1.404.
Oh, sorry, I skipped a decimal or a place value. You're right.
Yeah.
04. There you go. Okay. Thank you for catching that.
You're welcome.
All right. So this is a very basic level question. All right. Every single question that we do is going to boil down to something like this. So investing in this level is so important because it means that then you can solve all the other kinds of problems. Okay. All right. Let's try this one. Is the exponential isolated? No. So what do we need to move and how do we move it?
Subtract 200.
Perfect. In for the redemption. I love it. All right, so I'm going to end up with 1/3 to the x equals 100. Now my exponential is isolated. So I can rewrite it in log form. What's the base here?
1/3.
1/3, you got it, 1/3. So log base 1/3 of 100 equals my unknown. And if we want to type this into the calculator, we've got a log 100 over log 1/3. Let's see what that gives us. And I think I get negative 4.192. As an answer. And if you plug that back in for your x, then you should be able to make that equation true. Okay. Any questions on these first 2 examples so far? Okay. So let's move along. Now this we haven't really seen before.
Example. Can you just quickly go back to it? My Wi-Fi disconnected, so I wasn't able to write it down. I meant the first example. Sorry.
Oh, you're fine.
Oh. Thank you.
You're welcome.
And I'm good.
All right, thank you. Okay, so this kind of equation is a little bit different than what we've seen because one side has a base 4 and the other side has a base 5. And so we've only seen situations where the bases are the same or we can make the bases the same. So this one is not either of those cases. So here's what we're going to do. If we have things that are unknown, we can get them out of the exponent by logging the sides. And when we're solving equations, whatever we do to one side, we have to do to the other. So let's go ahead and log both sides. So log of 4 to the 2x plus 3 equals log of 5 to the x minus 2. Okay, so all I did was log both sides. Now, one of the properties we learned about had to do with the powers. What can I do with those powers?
Bring them down to before the log.
Perfect. Bring them down as a coefficient. Very nice. And then I can do the same thing on the other side. So I'll get x minus 2 times log 5. Okay? Now, this structure right here, we're going to solve for x, and it's going to get a little bit messier before it gets better. So just be patient with the mess. It will clean up pretty well. So the first thing we're going to do is we're going to distribute this log 4 to both the 2x and the 3. And then we're going to distribute this log 5, x, and the negative 2.
Oh, come on.
So that's going to give 2x log 4 plus 3 log 4 equals x log 5 minus 2 log 5. All right, so it's getting a little messier. But now what I'd like to do is I'd like us to group all the terms that have x on one side and all the terms that do not have x on the other side. So this term and this term both have x's. And I'm going to move them both to the left-hand side. Whereas this term and this term do not have x's, so I'm going to move those to the right-hand side. So I'm going to end up with 2x log 4 minus x log 5 equals negative 2 log 5 minus 3 log 4. Now, if I look at this left-hand side, what is the greatest common factor on that side?
X.
Yeah. So the reason why I moved all the ones in yellow to one side is so that I can factor out an x. So I get x parentheses 2 log 4 minus log 5 equals negative 2 log 5 minus 3 log 4. And what do I need to do to get the x all by itself?
Divide. Oh, no.
Yeah, no, you're right. Divide by what? Tell me what you want to divide by.
By the 2 parentheses, 2 log 4 minus log 5.
Yes, yes, that is exactly right. Okay, and such a good job looking for that structure because it's x times this whole thing. So if I want to get rid of it, just divide that whole thing away. And that's going to give us an answer of x equals negative 2 log 5 minus 3 log 4 over 2 log 4 minus log 5. And as messy as that looks, we're going to leave that because that is a very exact answer. Whereas if I start turning the logs into decimals, I'm going to end up with a lot of decimals. And every time I round, it's going to impact my final answer. Okay? So sort of a twist on that strategy where if you have bases that are totally different, you can log both sides and use the properties of logs to solve from there. Okay? All right. So let me do this. I'm going to have you guys start number 4, but I'm going to leave number 3 on the screen like that so you can kind of use it to guide your work. Okay? So let's take a couple minutes and get started on example 4 as much as you can. All right. So if we take a look at example number 4 here, right? Very similar structure to number 3. We're going to log both sides. We're going to distribute. We're going to say which terms have an x. Let's gather them all on one side. And which terms don't have an x. And we're going to gather those on the other side. And the reason for that gathering is so that we can find a greatest common factor, which should be the x. And then just like Michael said, we want to just divide by that whole thing that it's multiplied by so that we can get our final answer. Okay? Any questions about 3 or 4?
For the ordering, could I have done 3 log 2 minus 2 log 5 at the top?
Absolutely. I think some people might even prefer it that way because the plus sign is in the front.
Yeah, I see it better when.
Yeah.
Yeah, so.
Totally fine. I was just being lazy and I didn't want to switch the order on people right there. Okay. Any other questions on 3 or 4? All right. So let's go ahead and take a look at solving log equations, okay? During a normal semester, or a case where I didn't just meet you guys on Monday for the first time and then tell you you have a test next Monday. In a normal semester, these are equation solving ones that I would cover. I will include these in the answer key for you, but they will not be on, like, this type of question will not be material you are responsible for Monday's exam. Okay, so I will show the work for this in case you're curious about how to solve these, but given the short amount of time that we have known each other and worked together, this is not something that I will expect for Monday's exam, okay? All right, so let's move to solving log equations. Now, we also looked at a whole bunch of log equations earlier, so let's kind of look through these, and I might make decisions along the way about things that are valid for Monday versus things that maybe you don't have to worry about quite as much, okay? All right, so I feel like this is one that we can probably handle pretty well. I'll give you a moment to look over that, and then if you could share out like what might be one possible first step.
Isolate the 2.
Isolate the 2. Okay, cool. So we'll take this and we'll subtract it to the other side. All right, I like that. All right, ideas on what we do next.
Change.
What's that?
Division.
Division, yeah, we're gonna condense those logs. So log of 5x plus 1 over 2x minus 3 equals 2. Now, this might be a really good time to go ahead and write in that base because we don't have one written. So that base is a 10. Okay. What can we do from here?
Set 10 to the second power.
Good job. Base to the power of the number on the other side equals the thing that we are logging. Okay. Or we could say that 100 equals 5x plus 1 over 2x minus 3. All right. Thoughts on how to isolate my x here?
Multiply it by its reciprocal, make it not a fraction anymore.
Okay, so let's multiply both sides then by that denominator, 2x minus 3. So 100 times 2x minus 3 equals 5x plus 1. All right, good. Now from here, I bet if we distribute, that might be helpful, yeah? So we'll get 200x minus 300 equals 5x plus 1. Okay. And even though this has more numbers and less logs, it's kind of similar to our exponential equation where we're gathering the same term on both sides, right? Move all the x's to one side, move all the numbers to the other side. So what do we get? 195x equals 301. So x equals 301 over 195. Right? And I'll leave you folks to check that answer, but it should work out when you plug that back into the original equation. All right. How we feeling on these equations so far? Can't tell if we're quiet because it's a Thursday, or quiet because we don't get it, or quiet because we're like, we already get it. Keep moving.
I'm getting better. I think for me personally, I just forget certain things. Some that just just repetition.
Okay, cool. All right. So let's move on to example 2 then. Okay. What can we do here for number 2?
Condense the same logs on the right side.
Yeah. Okay. Now, while I'm here, I'm going to go ahead and distribute this to both terms there. Okay. So 2 times 3 gives me 6, but then there's an x on the top and an x on the bottom, so that's going to make the x's go away. And then the second term is going to be 10 on the top and x on the bottom, all right? Strategy here. What can we do from here?
Could you put both the logs on one side and equal it to 0?
You could do that, yeah. Someone else mentioned a strategy earlier, which was like when you have one log on both sides, if they have the same base, then the things that are being logged, they have to equal each other, meaning this has to equal this, okay? So you could certainly subtract 1 to one side and then end up with a division. Or you can jump right to saying x minus 1 equals 6 minus 10 over x. Okay? I think in this case, this way might be shorter, but there's nothing wrong with doing it out the other way as well. Okay? Now, I mentioned earlier that I really like to get rid of fractions if I can. And so when I look at this particular equation, I notice that there's one fraction. And that fraction has a denominator of x. So what I'm going to do is multiply the entire equation by x. So I'm going to get x squared minus x equals 6x minus 10. All right, so I took this x and I distributed it to every term in the equation, and that helped me get rid of the fraction. And now I see a quadratic, so I'm thinking move everything to one side, set it equal to 0, solve for x. So we get x squared minus 7x plus 10 equals 0, which, unlike that other one where we had to use the quadratic formula, this one is factorable. And in fact, it factors into x minus 5 times x minus 2. And so we can say that x equals 5 or x equals 2. Are either one of these numbers going to make any of these parentheses negative in value?
Yes.
Yeah, which one?
The log x minus 1, the 5, and the 2 both make it negative.
How's it going to make it negative?
Oh, sorry. Never mind.
Okay, yeah, so if it was like a negative 5, I would agree that that's going to make that equal to a negative. But 5 minus 1 is going to give us 4. 2 minus 1 is going to give us 1. So in this case, both of them should work, okay? But make sure that on an exam that you double check your answers, plug them back in, show that thinking so that you can confirm that the answers that you box are indeed the answers. Okay. Any questions on 1 or 2? Okay. We're going to skip number 3. Again, this is one that during a normal semester, or if we had more time together, is one that I would want us to know how to do. And I will post the solution for that. But since we've only been meeting for 3 days, I don't think that this is one as quite as important as the other ones that we've seen so far. So let's go and start with number 4 here, okay? So I see a log and I see the square root of x to the 3rd minus 9. And if we were to use one of the properties of logarithms, how else could we write the left-hand side?
I would say we set everything to the second power, like both sides, so we can get rid of the square root.
I can't get rid of the square root like that.
Okay.
Okay.
Would it be x to the 3/2 minus 9 to the half?
Close, close. It's going to be this. And because these two terms are connected by subtraction, I cannot distribute that 1/2 to both powers. Okay? I could if they were multiplied, but not if they're added or subtracted. But I love that you were able to identify that that power is 1/2. How do I get that power to be somewhere else?
Move it in front of the log.
Yeah, move it in front of the log. So I've got a 1/2 log of x cubed minus 9 equals 2. How do I get rid of that 1/2?
Multiply by 2.
Multiply both sides by 2. Good. All right. Now, great time to write in the base that you don't see, because now when you rewrite it in exponential form, Okay. So this is going to give us x cubed equals 10 to the 4th is 10,000 plus 9 is 10,009. And then I could take the cube root of that number. Or if I wanted to leave it exact, I could leave it like that. Okay. And again, I'll leave you to check this by plugging it back into the original, but this answer should work out to be one of the, or to be the solution for this question. Okay. So those properties of logs definitely are really helpful in just making things a little bit easier when we solve our equation. Okay.
I have a question.
Yes, what's up?
So if we have solutions like x equals to the third square root of that number,
Yeah.
would you want us to leave it like that or put it into decimal form?
I actually prefer that you leave it in the exact form.
Okay. Thank you.
Yeah. And so here's my reasoning for that. One, you don't have to type anything into the calculator. You can just leave it like that. Two, what if you type something wrong and then you get the wrong answer by accident, right? I don't want to take off points because you typed something in wrong when you had the correct answer. And then sort of this third reason is the higher you go in math, the more weird looking things we have to be comfortable with. And so I kind of try and start like getting you used to weirder things by leaving them as exact form. So.
Oh, okay. Thank you.
All right. All right. Let's do one last example here. Let's do example number 5. Okay. So take a moment, think about what strategies you might want to use to get started. And then in about a minute, let's share out some different strategies, see what people are seeing and how we might be able to answer this question.
Would you multiply the 3 in front of ln by the 2 exponent?
Ooh, you could. Yeah, you can definitely do that. So like take this 2 and bring it down here.
Yeah.
Yeah.
Oh, thanks.
Once I've done that, can I divide it six by both sides?
You could, but I would do something before I divide by that 6.
Okay.
Yeah, what is that something?
Add the 1 both sides.
Yeah, I'd move that 1 to the other side. Does that make sense?
Oh yeah, I already moved that. So
Okay.
I was
Yeah,
having
yeah.
for it.
So like this, and then yeah. Perfect. I don't remember who said it. I think it might have been David, but this, moving it down to the front, I thought was very clever. Sometimes I forget that one myself, but I think a lot of times it makes the rest of your answer a lot easier if you just move that power down right away. Okay, so really good eye there. I like that. All right, so we've got our log. We have it isolated. We need to rewrite it in exponential form. What is our base?
E.
E, I love it. Okay, so if you're totally there, you're like, I know natural log has a base of E, that's excellent. You can jump right to this. E to the first power equals x plus 1, okay? But if you're still like, oh, I don't know how she said that so quickly, another way to think about this is ln is log base E of x plus 1 to the 1. All right, so there is no shame in saying, I want to show this step so that I can get to that same step, okay? I think sometimes math instructors, your professor's not like this, your other professor's not like this, but sometimes along the way we encounter math teachers who were like, I mean, you should be able to do it in your head, and then we kind of feel bad when we can't do it in our head, and we keep trying, but then since we never write it out, we don't give ourselves the chance to learn. So I'm not that kind of instructor. I would rather you write out 10 extra steps and get the question right than to skip a few steps and be like, I don't know what I'm doing. Okay, so if you want to write this step here, no shame. I love that you understand what ln means. Okay, and if on the flip side you're like, I already know, I just want to go straight to that step, that's also fine. Okay, but either way, when you get to this, you just have one last step to get x by itself. You're going to get x equal to e minus 1. And again, e is a non-repeat, or it's a decimal that never ends but keeps going, but not with a real pattern, so it's an irrational number. So if you were to round here, you'd probably lose a little bit of that accuracy. I would just leave it as e minus 1, and that's actually considered a simplified answer. Okay, so I think we're going to stop here. I think this is a good place to stop. And in terms of Monday's exam, I think as you prepare chapter 5, I want, like, a lot of the conversations we've had, like, how do you know what steps to do next? That's the kind of work that I'm looking for when you do your work on the exam, okay? It's okay if you leave everything in exact form. You don't have to turn anything into a decimal if you don't want to, but you do have access to a calculator if you do want to turn it into a decimal form, okay? I do want to keep it, all of the questions on the exam, to be very much the same flavor that we've done in our lessons together. So for example, something like example 5, but with different numbers, would be completely fair game. Something like number 4 with different numbers would be completely fair game. But again, like questions that we skipped today, like number 3 here, I'm not going to throw at you and be like, haha, I just wanted to see who was really paying attention, okay? So as you're studying, really focus on what we talked about in the lectures, and that should be reflected on the exam on Monday.
I have a question.
Yeah, what's up?
So the chapter, like the test, does it include chapter 4 and 5 or just 5?
4 and 5. So whatever you covered in chapter 4 with your other professor, and whatever we covered this week in chapter 5.
How about the topics that was supposed to lecture on Monday, but because of the things happening? So are they going to be on the exam?
Mm-hmm.
Oh, thank you.
Yeah, so the anything in chapter 4 that was listed with your old professor is fair game. Okay.
I have a question.
Yeah.
On my math lab, it goes up to, for our homework, 5.6. I was wondering if that's something we're going to cover possibly next week, or for the homework, what should we do on that one?
Yeah, so 5.6 is all the applications. That should be all the word problems that we've kind of already done in all the other lessons.
Okay, thank you.
Okay, so it shouldn't be anything that we haven't covered. We just sprinkled it out throughout.
Thank you.
Okay, you're welcome. Any other questions?
Yes. Hi, I'm sorry. I'm still kind of confused on the policies for the exam. The ones that you stated before we started the lecture, like I'm still a bit confused on what you said we should do.